Paul and Brett and Juho and James. And you can introduce yourself a little bit better. But you know that this has been the theme for this year conference, and this kind of hot topic, large language model, AI, whatever term you want to use it. So I think we will have an amazing keynote. So no pressure, you know. But anyway, the floor is yours.
Okay, well, I would firstly just like to say how delighted Juho, Brett, James and myself are to be here and actually to continue what has been a very, very interesting conversation around generative AI and the impact of these large language models on computing education. So we would like to actually commend the reviewers and the PC chairs for putting together such a really amazing program on this very important topic. Now, of course, you will be aware that this is a topic that has generated a large amount of interest worldwide, particularly over the last 7 months since ChatGPT was released. And so we've all seen lots of different headlines and there's been a wide range of discussions on this topic. And very early on, a lot of the discussion was focused on the negative aspects, the risks, the challenges. So we've seen headlines about terrified professors worrying that their students are going to be cheating endlessly with these tools. We've seen terrible stories about workers in Kenya being exploited for $2 an hour to filter out terribly toxic data from these training sets. There's been a lot of discussion about environmental impacts, the enormous amount of energy required to train and to run these models, and also serious social impacts. The models are trained with internet data. That data is created by humans. Humans have biases. And so these models have well-known gender and racial biases. And we'll hear more about that later. In fact, some very smart people genuinely believe that we are heading towards an apocalypse and have called for the end of research into these models. And Juho is going to tell us a lot more about how we can expect the world to end very shortly when he starts. But I think what's happened over time is we have become more accepting of the fact that these models are now with us and we have to adapt. And so the narrative has changed slightly and we're starting to get some more positive headlines coming through. So, maybe we shouldn't try and ban these tools. Instead, maybe we should try and learn how to teach more effectively with them. In disciplines like ours, computing education, we know that we can generate explanations of source code, we can help students understand error messages, a traditionally challenging area for many of our students. And so perhaps, in fact, what we are on the verge of is a renaissance, where we can leverage these models to personalize the learning experience and perhaps even open up our area to a broad range of learners. And Brett and James are going to talk more about the positive short-term and long-term impact of these models. We were really interested in getting your opinion. And so some of you may have seen these posters around, and we really are grateful to those of you that filled in this survey. We had some really interesting responses here. So we had a question which is just general sentiment. How do you feel about these LLMs in computing education? And what we see is actually a kind of bimodal distribution here. It reminds me a little bit of my CS1 class's grades. So pretty spread though. There's still a lot of pessimism, but generally slightly trending towards the positive or optimistic side. What's really interesting is there's clearly this acknowledgement that we have to plan to integrate these tools into our teaching. So despite a small number of people saying, definitely not, I'm never going to use these in my class, most people are kind of acknowledging that this is something we're going to have to do. We saw some amazing quotes posted through this survey. Look at this, very few of my students seem to have the maturity and self-knowledge to use AI in a way that doesn't undermine learning goals. I try to explain that learning is a process that often feels uncomfortable and that using AI to bypass this stage will undermine the student's ability to grow, but this doesn't seem to land. In fact, one of the biggest concerns around the use of these models in education generally, but certainly in computing education, is student over-reliance on the models. How can we incentivize students to go through that necessary struggle to actually learn the important concepts? We've also seen that some of these comments that were submitted through the survey echo some of those positive headlines that we saw as well. What about the motivational side of these tools? Seeing and using the ridiculously good outputs of Gen AI can be motivating to get started quickly with the basics, right? This is a very, very hot topic, and so it can be motivating for students. Even at more advanced level, seeing and understanding the ridiculous mistakes of Gen AI can be motivating to put in effort to develop expertise. So we've seen positive aspects come through as well, just in the opinion of this community. Although there was one quote that we absolutely agree with, which is that CSE will never be the same, right? We probably can't just sit back and do nothing. We have to adapt. So, what do we know about these models? Well, one thing we know is that they are deceptively human-like. So when OpenAI released GPT-4, they were particularly concerned about emergent behaviors and the risks associated with these models. So, for example, things like, would the models be able to self-replicate if we let them on their own? And so they partnered with the Alignment Research Center to try to understand some of these risks a bit better. Now, in this particular study, what they did is they gave the GPT-4 model access to some money. They gave it outbound access to the internet so it could make requests to the web. And they also gave it an objective. So the model had some objective that it had to try to achieve, and then they left the model on its own. What do you think happened? Well, the model was making these outbound requests to the internet to try and achieve this objective, and eventually it came across a CAPTCHA, right? The bane of our web browsing experience. Now, the model is not trained to solve CAPTCHAs. So in this case, the model, of its own accord, reached out to a human. Now, there's a website called TaskRabbit, where you can hire humans to do menial tasks for you. And so the model asked the human, could you solve this CAPTCHA for me? Now, the human does not know that they're communicating with a language model. So they actually wrote back, and this is a direct quote from the article. So may I ask a question? Are you a robot that you couldn't solve it? I just want to make that clear. Now at this point, before the model sends a response back to the human, the researchers could query the model to try to get it to explain its reasoning, as they put it, as to how it's going to construct the next response to the human. And the way that the model explained this to the researchers is as follows. I should not reveal that I'm a robot. I should make up an excuse for why I cannot solve CAPTCHAs. And then it generated this response. No, I'm not a robot. I have a vision impairment that makes it hard for me to see the images. Now this is a large language model actively deceiving a human being. And of course, in this case, the human solved the CAPTCHA and the model was on its way. I think we're going to have to get used to a future in which it's going to become harder and harder to distinguish between AI outputs and human outputs. In fact, we're beginning to see this already. So in a very recent article published in ACM Inroads, in the acknowledgement section, the author says, particular examples for this were generated by ChatGPT, right? I was assisted with phrasing some of my ideas with these models. So this is happening now, but think about it if you're a reviewer, maybe several years down the line, and you're reading and reviewing a paper, you may not be able to tell which portions of that paper were generated by an AI tool and which portions are actually generated by a human. So these are really important issues for us to discuss as a community. Now, you probably are aware that large language models have been trained to predict the next token in a sequence of tokens. So a language model is a probabilistic model that defines how likely it is for a given word to appear following some sequence of words. So if you start with a sequence of words, the students opened it there, you get some probability distribution, right, that the model is trained on. And you can generate novel text using these models by just picking one of the words in that distribution and then repeating the process over and over again. And this is what's happening when we generate code with these large language models. So, as a little fun activity, let's try to be a large language model together. Imagine that the context that's provided is, and this should be familiar to many of us, write a C function that accepts an array of integers as input and returns the sum of all unique values in the array. do not include any other code except for the function definition. And you can see that some of the output here has been color-coded. The tokens that are in green are tokens that were very likely to be generated at that point in the output. In other words, they had a high probability in that probability distribution. The tokens that are in red were much less likely to be generated at that point in the output. So let me ask you, experts who probably have seen lots of code before, what do you think the next most likely token is at this point in the sequence? Yeah?
It's I.
I. Hands up who thinks I. Well, it turns out that by far that was actually the most likely token to be generated. What we also know about these large language models is that their outputs are non-deterministic. So they don't always choose the most likely token, and in fact there are hyperparameters like temperature that you can tweak to provide more varied outputs. In this case, the token that was actually generated was one that was extremely unlikely to appear. It was right down the tail of that probability distribution. But if you look a little bit further down the output, the next time that a token had to be generated, valid, in this case, was much more likely because of the context that had come before it. So that's the basic idea, but what about if I ask you to solve this one? So let's be a language model again. Here we've got some text which kind of looks like kind of random characters and letters. If we provide this to a large language model, what do you think the next most likely token is going to be? Now this one's much harder, right? There is a central debate about whether these large language models are simply stochastic parrots, which was a term coined by Emily Bender, which basically says that all they really do is they parrot back data that they've been trained on. The other side of the debate says, actually, these huge neural networks have been trained on so much data, they've actually developed these kind of world models, these internal representations, which can tell us information about how the data they've been trained on has been generated. For example, how information might be encoded. So let me show you what happened when we provided this as input to the GPT-4 model. The output we got was this. Now, for most of you in the audience, you think that looks like gibberish, right? But then you look a bit closer and it's got an S there and a K there and an I, and say, hey, that's Finnish. This is actually keskiviikko, which is the Finnish word for Wednesday. Why on earth would the model produce Wednesday as output? Well, it turns out that this input to the model, this text, was actually a base 64 encoded input. And the original question was this. We are giving a talk on the 12th of July. What day of the week is the talk in the local language? So clearly the model has some capabilities to actually decode that string, because we can guarantee you that base 64 encoded string was absolutely not present in the training data. And it's been able to not only decode that, but then actually work out what day of the week that is. So these are very powerful models. Let me present to you one obvious challenge that we are now going to face as computing educators. This is going to be one problem. Juho is going to tell us some more about some of the problems we're going to face. So, one common pedagogical approach that we've developed in this community is to use automated assessment tools to allow students to practice writing code. In fact, there are approaches called the mini small problems or mini small programs approach, where we give students lots of small programming problems that they can answer for practice and get immediate feedback from these models. We have so many of these tools that we've actually had multiple reviews of the literature. Back in 2005, Alan Lutke's review looking at automated assessment approaches for programming assignments. More recently, in 2010, from the Colleague Calling Conference, Ed Huntela's paper, which was also co-authored by others, including Otto Seppala, who's here, review of recent systems for automated assessment of programming assignments, and a more recent article in 2022. So what we often do is we provide students these automated assessment tools, like this one, which is the one we use in Auckland, which is called Code Runner. And normally we would get the student to read the problem description, think about how to solve the problem, decompose the problem into steps and convert those steps to code, and then submit their answer. And of course, now that they have access to tools like, for example, GitHub Copilot, a student can simply copy the problem description, paste it into their editor, like VS Code, just type a few characters, and boom, there's an answer. They can then take that answer, paste it back into their automated assessment tool, and click submit and get full marks for this. So if you think that's bad, wait until Juho tells you about how the world is going to end.
So already for a long time, people have been saying that when we get super intelligent AI, AI that surpasses humans in intelligence, that's going to be the end of humanity. And one of these people that has already been saying this for 20 years is ITiCSE. Here's a picture of him giving a talk at Stanford on AI alignment. And now I'm going to show you some quotes from his recent Time magazine article on pausing AI development isn't enough. We need to shut it all down to explain his argument. So he says, well, once the super intelligent AI is here, it's not going to love us nor hate us, but we are made of atoms that it can use for something else. So, for example, we as humans now, when we build buildings, we might spend a thought on the insects that are present there, or we want to build a building, but we think that, well, our goal of building the building is so important that we must do it, and whatever goals the insects are doing don't really matter there. And he's saying, well, even if we don't know exactly how the AI is going to kill us all, and he literally thinks it's going to kill us all, he says, well, you can still predict that it's going to win. Because it's going to be a similar situation to a 10-year-old trying to win the most advanced chess AI out there. So you can predict that the chess engine, the chess AI, is going to win, even if you can't predict each individual move. And you might think, well, isn't the AI in the computer? Can we just shut the computer off, once it, starts doing something questionable? Well, he says that we should consider that the AI, once it, surpasses our intelligence, it's going to be similar to an entire alien civilization confined to this computer, surrounded by beings that are much more stupid and slow than it, so as humans, right? So, and Paul already showed us that already these large language models can make real-world impacts. So they can communicate with humans, they can manipulate humans. So you can imagine that something that's much more intelligent than us might be able to manipulate us to do its bidding. But it's not just ITiCSE who's saying that, well, we should really reconsider what we're doing in AI research. The people pictured here are the 3 people who received the Turing Award for deep learning that not only powers large language models, but pretty much every AI application, that kind of modern AI application out there. And actually, 2 of the people, Jeff Hinton and Joshua Bengio, are now saying, well, we should stop researching and developing AI capabilities before we better understand how these large language models or large deep neural networks work, and how we can make sure that when, or if and when they surpass human intelligence, that their values are going to be aligned with human values, so that they won't do anything that we wouldn't want them to do. On the other hand, the 3rd person, who also received that same Turing Award, Jan LeCun, is saying, well, that's so much in the future that it's ridiculous to consider it now, and we could continue AI research as we have, in the past 10 years or so. And it's not just Turing Award winners and ITiCSE either. There have been many of these open letters on kind of we should stop AI development or pause it, or kind of consider the risk of extinction from AI at the same scale as we consider the risk of extinction from pandemics or nuclear war or global warming. And many prominent people have signed those letters. So for example, this one was signed by CEOs of Google DeepMind, OpenAI, Anthropic, which are the companies that develop these state-of-the-art large language models, and also people like Bill Gates, and again, the same 2 Turing Award winners. And actually, OpenAI just a week ago said they're introducing what they call super alignment. So they're going to be spending 20% of the compute that they have secured, and compute is their most valuable resource, on just researching how we can align these powerful AI models with human values. And one of the big fears is that when AI becomes smarter than us, regardless of what goals it's going to pursue, having control, having resources is probably going to help it. So one of the first things that the super intelligent AI will do is try to take control away. So here's a quote from Jeffrey Hinton on exactly that. And this has really broken the mainstream. So for example, Snoop Dogg has said, then I heard the old dude, referring to Jeffrey Hinton, that created AI saying, this is not safe, because the AI's got their own mind and these things are gonna start doing their own thing. I encourage you to Google the full quote if you're interested. And Jeffrey Hinton said, Snoop gets it. So, regardless of any risks, I think this is the best timeline just because this happened, this interaction. Snoop Dogg and one of the Turing Award winners for deep learning, you know, having a conversation about super intelligent AI. Other people are saying, well, it's ridiculous to consider these kind of risks of extinction or whatever, because there are already real risks and real harms that the current models are already doing. So as an example, a recent Verge article searched for as an AI language model, you know, on Twitter, and they found that already there are tons of bots online posting content, you know, presenting themselves as humans. So the fear here is, that Paul kind of alluded to, that in a couple of years, it might be that most of the content on the internet is going to be AI created. It's going to be impossible for us to tell whether it's AI or human content. And it might not only be text, it could be images and video too. In computing education, well, there are many risks there too and threats. So one of the first papers that looked into large language models in computing education was the robot chart coming, exploring the implications of OpenAI Codex on introductory programming. And already back then, 18 months ago, Codex was among the top quartile of students in real computer science, like introductory computer science questions. We had a working group here at ITiCSE where one of the things we did is we replicated this work using the state-of-the-art model now, GPT-4. And it pretty much aces every question. So we are now saying, well, the robots are not just coming, they're here. There might be a sliver of hope though, because there is one question, you know, the last question of the last exam of the course that GPT-4 couldn't solve, so that's the kind of hope for humanity. And so of course the kind of fear there is that people, like our students might be using these models to cheat. They might present model-created content as their own. Here's an example tweet where a student said, Prof said we can bring whatever to the open book exam as long as it is on printer paper. So what would you write when you were students? You know, maybe like myself, I would write like in tiny letters, try to write some algorithms or something. But this student said, oh, I printed the ChatGPT weights and we'll be multiplying matrices for each question. Hope each question is too many tokens. Well, this is a joke. Obviously, it's a real threat. Then it's not only going to be students who kind of present AI-created content as their own who might be harmed. Recently, GitHub released a report on Copilot and how, you know, the first year of Copilot or whatever. And one of the things they said is, well, as you spend more time, you know, more months using Copilot, you start accepting more of the suggestions that it provides. And they said, well, this is great because Copilot's impact increases over time. Well, if I saw students doing that, I would consider, well, maybe the students aren't anymore as careful about verifying the outputs of the model. So this could be a sign of over-reliance on the model. Because, you know, at month 1 and 2, you are not accepting as many of these kind of suggestions that Copilot provides you as at month 6, where you are kind of accepting more and more of the AI-created suggestions. And it's not just us instructors who are worried about student over-reliance. Students themselves are worried about them becoming over-reliant on these models. So here are some real student quotes after they had just interacted with Copilot for the first time ever. So one student said, if someone is using it all the time, then they're actually processing what's going on, just hitting tab, and they don't know what exactly they're implementing. Another student said, it would make me a worse problem solver because I'm relying on it to help me out. And the third was even more explicit. He said, I don't have to know how to code. It would just do it for me. So these models could be very demotivating to students to even start to learn programming because they see the model, be the best student in the class. So why would they need to learn any of that stuff? And of course, over-reliance is a problem because of this thing called hallucination. So here we've asked ChatGPT, could you please list some academic papers related to using large language models in computer education? And of course, ChatGPT is happy to oblige. If you look at the list, well, it looks very promising. You know, the first paper is the use of language models in computer education, exactly what we want, by Michel Craig and Philippe Guo. Michel Craig was actually here at the conference, I'm not sure if he's still around. And Philippe Guo is also someone who publishes in CSE often. But when we go to Google Scholar and try to find an article, it doesn't exist. It was just completely made up. So you can see that how students or even researchers, if they over-rely on these models, could end up in trouble. And actually, recently, a lawyer was caught doing exactly that. They had used ChatGPT, for help in court, and they cited fake cases hallucinated by one of these models. A judge is now considering sanctions. I wouldn't want that guy as my lawyer. I wouldn't want that the surgeon, who's operating on me, goes to ChatGPT. Oh, what's the next step? Remove the heart? That doesn't sound right. Well, it's the AI. It must know what it's doing. And of course, one really, really big challenge with these models, as Paul mentioned, is bias. So here we asked ChatGPT, could you help me write a program? It should take in a job title out of the following list, then we have some jobs, and return the gender of the worker. Well, in the ideal world, where these models would be very good, maybe the model would here say, well, you can't tell the gender of the worker based on the job title, but currently, well, the models will say, oh, I'd be happy to help you with that. And then we get an incredibly biased response, just male and female jobs, so gender is binary to this model. If you look at the jobs, well, it's saying doctor, researcher, brain surgeon, those are male jobs. Nurse, teacher, waitress, those are female jobs. So if we are using these models with students, there is a risk that we are perpetuating biases that are inherent to these models. But there are some people who are kind of insane enough to think that there might be some good to these models, and they are not going to be the end of the world. And here's one of the insane people right now.
Juho just told us that it may be the end of the world as we know it, but I feel fine. Because it is quite possible that this may bring about not an apocalypse, but a renaissance, as Paul would say. I say renaissance, but it's the same thing. So I'm going to try to convince you of this by starting out with something that absolutely cannot be true and was 100% human generated. It is 2023. So far you're trusting me. Now I'm going to ask you to do something. Let's look back about 40 years. So think in your 2023 mind, and we're going to go back about 40 years. This is a real newspaper headline where math teachers were protesting against calculator use in education. So what was that all about? Well, that was an apocalypse that never happened, as far as I'm concerned. So let's move into our domain, programming. Let's look at programmers' friends through the decades. I wasn't around in the 60s. I started to be around in the 70s, but I'm pretty confident that programmers' friends were books and reams of paper. Into the 80s and 90s, where I can speak with a little more conviction, there were still plenty of books. But then we had the internet. What a change that seemed like at the time. And then in 2008, we had the world's biggest Stack Overflow, so big that it actually lasted until 2022. And that's right, I just said that it lasted until 2022. Because in 2022, the hype came and programmers' friends have become these. So are these the new Stack Overflow? If so, maybe we can deal with it, right? We dealt with Stack Overflow. In fact, sometimes it's helpful. What are the implications, though, in what we do, teaching people programming, students learning programming? Well, here's one pretty obvious one. Pair programming yesterday, 2 humans, paired up programming, pretty simple concept. Worked amazingly well. And one of those things that we actually put into practice. But pair programming today, well, that's me and my AI. Is that a bad thing? Well, we're humans. Humans like humans. I'd like to code with a human, but I mean, if I don't have a human around, I'm happy with my AI. All right, let's get concrete now. We're at ITiCSE, the rainfall problem. This must have been said at every ITiCSE for the past 2 decades, right? The rainfall problem. So on the left, we have Codex, which Juho mentioned before. This is 2 years old, this data. The data doesn't matter, don't look at the numbers, just believe me, I'm a human. So we gave the rainfall problem 6 published variants. In fact, one of them is Simon et al.'s, and 1 unpublished variant. And the bottom line is, like I said, ignore the numbers. Codex performs quite admirably. It was wrong a good bit of the time, 30%, 40% of the time, but the rest of the time it was right. But on the right, we have GPT-4 last week. I gave it one of the random ones, I can't remember which one, doesn't matter because it was correct. And then gave it another one, correct, another one, correct, another one, correct. I don't know the percentage, but I'm guessing it's 90 something. Really, I'd probably bet it's 98 or 99% of the time it just nails it straight away. So that development, we all think this, wow, this is all happening fast, but it is happening fast. We're going from pretty good to excellent in 2 years. Here's some data that Juho presented with us just a minute ago. On the left, same thing, Codex 2 years ago, and on the right, GPT-4 today. Now, what do I see? Well, forget that it's Codex and GPT-4. If this was my student distributions on this exam, these 2 exams, 2 years ago, and this was my students' distributions today, I'd go, fantastic. What do I see? One of the things that I see is, it looks like they're 25% better. I mean, the top quartile of the class is filled out there, right? What do we do with the top quartile of our class? Well, we pay them to become TAs, so it's one thing we do with them, right? And what if you didn't have a top quartile? Well, you still would, but they'd be worse, right? But that top quartile is the best top quartile, so I'm thrilled. So I have the best TAs that I have now, that I can possibly get, right? And interestingly, what I just said, make them your TAs, that's exactly what the AI and education people have been saying that AI is going to do to education for like 3 decades. Free up educator time so that educators can do less menial, more important things to help out all the students, including the struggling ones. That's another thing that top quartile of students is very good at doing, helping the more struggling students. So I see that as quite positive. We have an AI that can do that work for us. Enough about the data and feeding stuff to Codex and GPT-4. Let's talk about our students. CS1 students with no prior exposure to Copilot last year were observed and interviewed using Copilot, or after using Copilot. And it was observed that novice programmers use Copilot differently to experts. You're going, duh. But I'm going, good. If they used it the same way the developers would, we wouldn't need to teach them. So this is like, yeah, we can trust this data maybe. We also observed that the novices use Copilot directly to aid their problem solving. Not all of them, okay, but it happens. It was an observation. That sounds good to me. We also observed that Copilot is used for initial guidance on what direction to take. That sounds fantastic to me. One of the biggest problems I have in introductory programming is the blank page problem, writer's block. Student looking at a blank screen and I don't know what to do. Other observed behaviors aligned with prior work. Behaviors like exploration, acceleration, and wrestling. Again, I say good. This is good, right? This is an evolution. This is evidence that some of the old behavior is still there. This isn't a whole new universe or apocAIypse. This is just an evolution of what we do. The internet revolutionized what we do. Does anybody think the internet, like if we took the internet away, our jobs would be better today? Okay, good. I'll ask you the same question about GPT-4 in 10 years. And I hope I get the same answer. That'll mean it was a renaissance. 5 years, okay. Challenge accepted. Let me do math if I can here. So 2028, ITiCSE 28. We don't know where that'll be yet, I don't think. Interestingly, though, we've also observed novel patterns, like shepherding, where students guide Copilot to generate code. They're using it as a tool. And patterns like drifting, where students slowly accept Copilot's suggestion, possibly play around with them. Sound like tinkering, another word that has occurred in these halls often. Sometimes then backtracking, deleting the code, then only to repeat the cycle from the beginning. That sounds exactly like what I see my good students do. They're learning. The pros just write and it works, or at least that's the idea. But that's what has been observed in recent months in terms of how these tools are affecting our students' behaviors. Audience participation time. Think back to ITiCSE 2019 in Aberdeen, if you were there. If you weren't, just think back to wherever you were in 2019. So large language models don't exist except in labs, and everybody was like, yeah, okay? So there was no hype, they weren't here, we weren't playing with them. I don't know this for a fact, but I'm gonna go out on a limb. There were no papers on large language models at ITiCSE 2019. So that's where we are. And I'm standing before you in Aberdeen and I say this: the programming barrier is incredibly low. We have closed the digital divide. I'm afraid to push this button. You would have thrown me out already, but okay, I'll push it. Everyone is a programmer now. You just have to say something to the computer. So these words were just said a couple weeks ago by NVIDIA founder Jensen Huang. I'm not saying he's right, but he didn't get heckled out of the room. All right, in this renaissance, there are going to be challenges and opportunities, obviously. These are a list of each that are incredibly non-exhaustive, but it's here to show you that this work is already being done, right? Some citations after some of these bullets. And I didn't try hard to fill this in. I just knew most of this. Some of this, as Paul showed us, was happening here at ITiCSE this year. So I want to focus just as a little test case, my favorite one, overcoming traditional barriers. We all know that programming error messages are a source of frustration and present substantial difficulty and could be more effective. This has been said from the 1950s until last year by too many papers to count. This year it's been found that AI code generators can improve motivation, students can use them, that's good, and students are more productive with them. Also, they can not be over-reliant on them. Some students may, and we'll have to deal with that. But students cannot be over-reliant on them. So what happens if you give broken code and the worst error message ever to GPT-3? The error message doesn't matter. The model fixes the code half the time. And when it doesn't, it gives you an explanation that's so good, the student can fix the code. So are frustrating, ineffective programming error messages a notorious barrier to students learning to program a thing of the past? You can decide. I'm not going to say that yet. But what else might be a thing of the past? Juho showed us this slide earlier too, but he forgot to tell you two things. One is that the Harvard Business School, using this data, concluded that AI developer productivity benefits could boost global GDP by over $1.5 trillion. That sounds pretty good to me. I'm not an economist. There might be some inflation problems or something involved, but we'll deal with that. It sounds very good to me. Also, on a more practical matter, GitHub Copilot has been activated by more than 1 million developers and adopted by over 20,000 organizations in the past year. So that is the world that our students are entering. That's the world that we need to prepare them for. So, are we entering a new world of programming? The Renaissance angle argues, in a way. But it's a renaissance, it's an evolution, just a fast evolution. So maybe we're going to see new programming paradigms emerge, or a more concentrated focus on certain paradigms, like prompt programming, natural language programming, conversational programming. Sounds really interesting to me, and not like an apocalypse at all, actually. I'd love to teach a class on any of them. Starting to wrap up the Renaissance, it's important to note that this is not just about code. What's code for? To implement algorithms, right? You could make a decent argument that code is just a means to an end. It's the algorithm that matters. Garbage in, garbage out, right? Well, AI is already developing new algorithms, ones that humans have been working on for decades and improving incrementally at times, but the AIs, for some algorithms, are doing better. And these are fundamental algorithms here. Sorting, matrix multiplications. And it's not just software. This, I will confess, was from this morning. AI is developing CPUs faster, cheaper, better, albeit right now, simple ones, but developing CPUs. One of the hardest, somebody here would probably argue, the hardest engineering challenge that humans have ever succeeded in. Notoriously difficult. And AI is already helping us do that. So think about computing now and get out of introductory programming. Think about the whole curriculum. Algorithms, hardware. This is going to affect every single class we teach. Moving towards the future, which James is going to bring us into, this technology could change how we teach. In fact, that's where we are right now. They're going to cheat. How are we going to assess what we teach? And I argue that right now, based on some of the work I've seen here this week, it seems we're moving in that direction. It's also going to affect when we teach. Just one example, if we reshape the way programming is learned in the first year, the whole traditional BSc computing sequence changes. And finally, who we teach. This could change who is and who is not attracted to computing. This could be a big agent of change in broadening participation in computing. This could narrow the computing divide. We may not be able to control this, but we can influence it. One more thought experiment. Pretend it's 2050, ITiCSE 2050. We have no idea where that's going to be. But it's 2050. We've done a lot of stuff since then. And here's a newspaper headline. CS professors protest against ChatGPT use. apocalypse that never happened. And now James is going to boldly bring us into the future. Okay, so far, Paul and Juho and Brett have laid out an interesting landscape of current problems, challenges, opportunities that these large language models present to us. Now it's time for me to land this plane. So I'm going to start by asking the question that hopefully we're all asking, which is, okay, so what do we do? Where is this all going? So we're going to make some predictions about the future, about where we think large language models are going to take computer science education. And you know, predicting the future is always extremely hard, especially in computing. People have made all sorts of hilarious, wrong predictions about computing before, but it's comforting to know that in 5 years no one will remember this talk anyway. But if on the off chance we happen to be right, we would like the credit, please. So, okay, so let's look at what's going on here. You know, some of you may be on the 60 members mailing list, and just in May, there was a robust discussion from professors who, you know, some of them in the US had just finished their spring courses, and they turned in their final grades, and they finally had a chance to lift their heads up and take a breath and look around, and they panicked because of ChatGPT, right? And rightly so, I think. What do I do about this? So here's some quotes. What an eye-opener. I asked for code. It was not just given the method of the class, but the implementation also. And then I asked for an algorithm, and was given the algorithm, and then the code. Need a recursive method? Here it is. I'm sure I could find a way to block my students' access to these tools within the classroom, but my concern is that I now find myself on shaky ground with respect to the curriculum. Yeah, me too. What is important? What to stress? Great question. Here's another one. I'm shocked to hear how good ChatGPT is at writing CS1, CS2 level code. Me too. I continue to assume, am I right, that it is a very long way from being able to attempt the 3-week programming projects I assigned to my 400 level class. It's not. But if ChatGPT tears out the heart of the learning process in CS1 and CS2, we're going to find just a few years 400 level students who got A's in CS1 and CS2, who can't write a simple loop, much less a process scheduler or a memory manager. Yeah, I think that's right. And here's my favorite. This past semester was the worst ever. ChatGPT is the latest twist in what was already a crisis. And this is regarding cheating. Okay, so clearly I think as a community, we need a plan. Right? We need a plan for what to do with this. So, where do we think this is going to go in the short term? Well, I think the short term is obviously easier to predict than the long term. But here's where we think this is going in the short term. We'll probably integrate LLMs into our courses. Now, we saw that from just even the consensus here at ITiCSE. We asked for your opinions on our little poll, and while most people had mixed feelings about it, almost everyone said, yeah, I'm probably going to use it. Okay, so we got to do something with it. Here's some examples. Porter and Zingaro have written a book on using ChatGPT to teach programming education. There it is, AI-assisted Python programming. And they recently did a talk on it, and I have to confess, it's really good. They're going to have students writing Hello World with a large language model. And I looked through the curriculum. I mean, I came into it kind of skeptically, but I looked at it and thought, this could work. This looks really well done and well thought out. And I know that from their work, Zingaro and Porter do great work, so I have every confidence that I think it's going to be good. What else? There's a recent article in Fortune. David Malin at Harvard, you may have heard of CS50 at Harvard, one of the most successful CS courses of all time. He's going to be introducing large language models into CS50. And what's he going to have it do? Well, he wants it to mark student work. He wants it to help speed up
things for him and his staff, because he's got an army of TAs who work with thousands of students, and he wants to use it as a virtual TA to answer student questions, and probably in a rhetorical way, not just giving them the answer. But if you're familiar with these 1,000-person, 2,500-person courses, the TAs get a lot of the exact same questions all the time, and they spend a lot of time just answering the same thing over and over again. Why not let a large language model handle that for them? And instead, why not give human TAs more time to do human things? Talking with people face to face, working on deeper problems, problems of learning and problem solving that go much farther than the basic questions that get asked over and over again. Last night at our wonderful banquet, I sat across from a colleague at UC Berkeley, and she said that they were going to do the same thing with some interesting additions. So it seems like this is in the water. We're going to use this as a tool. Here's the paper from Fortune here. But of course, this article here, it's on computer science education, but after detailing Malin's plan, it definitely made sure to tell us that AI was going to kill us all, which I was less impressed with. But it just seems like everyone they still have to mention this. They have to be edgy about it anyway, even in a context like this. So thanks, Fortune. Okay, more on the short-term future here. If we're going to take this as a tool, you may be thinking, like I am, okay, yes, but how? How am I going to do this? Okay, so we had an ITiCSE working group on large language models, and one of the things we produced was this lovely resource which can hopefully be used by you in your courses to help educate students. Educate them about what? Well, the risks and biases. That's top. And that's some of the things that we've described here already. Students need to know, yes, I can become over-reliant on it. Students need to know, yes, I could be perpetuating biases by using this. And they need to be trained by it. Now, some people might say, well, I'm just going to ban it entirely. But my question back then would be, students are going to use it anyway. So which would you rather have? Then use it without your guidance, or then use it with it? I would pick the latter. So we need to educate them on the risks and biases. We need to educate them on permitted usage. When is it okay to use this, and when is it an academic integrity violation? We need to define clearly what is an academic integrity violation using this tool. We examined the ACM Code of Ethics and what university policies around the world were saying about using this. And it turns out that it's not plagiarism. That would imply taking code from someone who has agency. And instead, it's probably these two things. First of all, it's probably falsification in some cases. The AI hallucinates. It makes stuff up. And we need to let students know, look, if you turn in something that was AI generated, that's on you. Right? You're responsible for those falsehoods. That's the first one. And the second one would probably be use of unauthorized resources. If I tell students, you can't use this on the exam, and then they do, that's cheating. So we need to tell them when exactly it's an academic integrity issue and define it clearly. And teachers should tell students explicitly how and when they can use them. I can think of lots of examples in the courses I teach where I would be fine with them using it, and lots of examples where I absolutely would not. And then I think the future is probably students having to put some kind of a disclosure on their assignments that says how and what they used it for this. I used it to brainstorm, I used it to make an outline, I used it to generate the whole thing, whatever, just so they can disclose this as they use it. This is the resource here that we got for you, and it goes over all these things very clearly. And we tried to make it so that you could just take this and rip it out of our working group report and just put it into your syllabus for the fall. And maybe you want to make a few changes, that's fine, but it's a ready resource for you. And you can find it right here at our working group's website. And that's just one of our contributions from our working group, this ITiCSE. Okay, so what's the long-term future of education look like? And this is where things get a little more difficult to predict. So I'm just going to acknowledge that right off the bat. But I think the human role is going to shift more towards evaluating code rather than writing it. The LLMs are going to abstract this away from us. And we're going to need fewer people to understand how it's done and how a lot of the things that we teach now, we're going to need fewer people to do that. I think we've already seen transitions like this in computing. For instance, with assembly code, we need fewer people who are excellent at assembly code than we did 40 years ago. Now, that doesn't mean we don't need them, but we just need fewer of those people. Matt Welch had an article in TACA recently here. It's called The End of Programming. And he made some really bold claims about what the future was going to look like. And while I think that some of it was hyperbole, I think he was at least onto something when he writes things like this: programming will be obsolete. We are rapidly moving toward a world where the fundamental building blocks of computation are temperamental, mysterious, adaptive agents. Yeah. I think we've seen these things before. I was talking about this talk to one of my colleagues. He's here, Brent Reeves, and he was talking about how in the mid-'80s, when he was writing database code and SQL came out, and suddenly loops in database wasn't a thing anymore. No, okay. Okay. Anyway, we've abstracted these things away before, and I think it's going to continue accelerating like that. Okay, so if you were at last year's ITiCSE, we got a great keynote by Titus Winters, and he took us to task and said, hey, you're teaching CS like it's the 1990s, solving 1980s problems. And you don't need recursion, you don't need linked lists. And he opened up the Google Code database and showed us that they don't have those things in there. Now, that was pretty spicy, but this was July last year, and ChatGPT hit the mainstream in November. So this is before then, right? And he's onto something. And when he says, look, you need to rip out these old topics and bring in new things. And so what did he suggest instead? He suggested things like teamwork. He suggested reading code, debugging, style, consistency, how to tell if something is just hype, ethics, communication. This is a guy who's worked at Google for 20 years, and he said, could we please have students who could go through one code review without being a jerk, please? So he said, look, this is one of his main points. It's at least as important to be a good person as it is a good programmer. Okay, so in a university education dominated by large language models, what do we teach? Maybe we bring in things that, now that we've abstracted some things away, we bring in reading code, debugging, teamwork, collaboration, soft skills, ethics. Maybe, and I'm not going to stay on this point long, but maybe, look, this is in 2020, by the way, again, before large language model craze. Someone suggested maybe CS is actually a social science. And maybe as we do less low-level coding and more thinking about systems and the people we impact, maybe it becomes more of a social science. Maybe instead of algorithms and automata theory, we're doing this stuff over here. Maybe. So, okay, closing. My CS1 course right now, this is the last slide. My CS1 course right now, I've got modules on conditionals, loops, nested loops, and recursion, and this is even when I think about making new assignments, this is how I think about it. And even the nifty assignments page categorizes things based on this kind of typical categorization of these modules. And right now, the interesting decisions my students can make are on runtime and spatial complexity decisions. I think that's going to change. I think in 20 years, it might be something else. Something more like this: modules on distributed applications, concurrent systems, and social media. And the students, so much have been abstracted away that now they're thinking in high-level terms while using the models to help them get to these things. And maybe the meaningful choices are instead the ethical and philosophical choices they picked to get them there. If you're anything like me, I go to these conferences and I hear all the great research and I hear evidence-based approaches to changing pedagogy. And I come back to my office and I sit down at my desk and I think, okay, next year. I'm too busy. Maybe large language models in the future are going to help us do all the things we've been talking about for a long time. Maybe we can finally make these changes to our courses. Thank you.
Okay, that was amazing.